All right, so I think yeah, okay, I've got a little recording button in the top left. So yeah, welcome to the first ever coffee morning. So I'm going to do coffee and code semi-regularly, I think, just for a chance for new members to drop in and say, hey. It's always going to be really, really informal though, because I don't want to be planning, like a robust workshop every single time we have coffee and code morning. So a really short introduction. In terms of the shared goal, let me just jump. Yeah. So in terms of the shared goal, I haven't made that because I want to be a bit organic with it. And if people have got a really nice idea for a way of phrasing what we're trying to do, then I'm more than happy for it to be a kind of collaborated statement on what we are trying to achieve. But when I first made this community, the sort of users that I had in mind were, they fitted sort of two criteria. First of all, people who were working as educators, and those that were working to teach with code. And I keep using those three words, teach with code, because I want to be clear that we're not just trying to learn code here. We're trying to figure out how we can use code within different academic subjects. So myself as a science teacher, I'm not trying to think, well, how can I teach my students Python? I'm trying to figure out ways that I can teach science with Python, so that I'm not losing class time and science instruction time, but I am teaching my students a valuable skill in the process. So that's kind of, when I made the community, that's the criteria of the type of people that would join. But I have noticed actually that a few attendees that have registered, and also a few people that have joined the chapter, they've listed careers that aren't in education. And I'm not going to say that's a problem immediately, because that could actually give us some valuable insight into ways that code is being used in other career areas. And that could really help us to build sort of authentic opportunities within our, like me as a science teacher, if I can speak to one of the people who have registered as a radiologist. Now, if I can get some insight into how code is being used in the field of radiology, and then bring that into my my science unit on health and disease, well, that's fantastic. So I'm not panicking. I'm not immediately slamming on the brakes, seeing that some people who are joining aren't full-time educators. I think that's fine. The only hard rule I really want to have is I don't want this to become a space that educators are sending their students to. So I do want this to be mostly a space for people who have graduated from high school and who aren't in education. So I want to make sure that this is age appropriate, and that we're not at risk of like personal data belonging to minors being shared. And I think that makes perfect sense. I think it's going to be a much easier community to manage if we're not having to worry about that. Okay. By the way, guys, also do use the chat feature if you want to throw in a question or a comment while I'm speaking. I'll keep bobbing back and forth to the chat, or actually just speak up. There's not too many of us here. So the code of conduct I've got on this slide, I've actually just copied and pasted it directly from Codecademy's code of conduct for chapter leaders. So I'm kind of just using the same rules that I've been given and passing that straight on down to the community. So the what's okay section is a really nice section for giving us a feel for what we want the community to look like. In terms of what's not okay, I think that's fairly obvious as well. We don't want this to become a space that people are using to try and push sales or to try and drum up fundraising. So we just want this to be focused on helping one another to build projects, and we're really not interested in pushing services. Now that second one, don't post text or images that contains private or sensitive information. That's quite a big one for us, because if we're a community of mostly educators, we need to make sure that we're not sharing anything that links to our students in any way. So for example, I've been making an article where I talk about presentations that my students made using research they did with Python. I've made a copy of those presentations so that it's not linked in any way to the student's account, and I've completely scrubbed those slides of anything that could identify the student in any way. And we need to be really, really careful about that. So I'll try to keep a vigilant eye out for things that are being shared to make sure that they don't in any way tie to students. But I'm hoping that all of our members can do that as well. Yeah, the other two are basically don't be mean, don't be cruel. So we're not going to harass or personally target one another, and we're not using this as a space to recruit for other organisations. Okay. I'm not sure where that code of conduct is going to live. Maybe I should make a document as we sort of grow as a community that we can refer back to and that new members can refer to. Because I don't want to be going through the code of conduct every time we have a coffee morning either. So I'll try and think of a shared space where we can have access to the code of conduct. Any ideas on that? I'm open to suggestions for maybe a space where we can have these permanent sort of living documents, because I'm sure the code of conduct might change as we realise that we need new rules. Okay.
Yeah, I wonder, as you join the community, as you join the chapter, there's a communication there, as in you have officially joined the chapter, that this should be part of that first email.
That's a really good idea. And that email is it's automated by Bevy, which is the name of the sort of social platform the Codecademy are using. So I'm wondering, actually, I'll make a note of that question, Samuel, because maybe Codecademy can check with Bevy to see if we can change those automated emails and make them a little bit more chapter specific. And I'm also wondering if we can have some kind of just, as a teacher, I'm jumping straight to the idea of a Google site or just some kind of static information page that people can access for things like this. Yeah, and maybe the other because as I go through these slides, there are a few other documents that I've made that are in different spaces. So it'd be really nice to have a central space where we can tie these things together. So maybe the answer is a Google site. Maybe there's a better solution. Maybe one of our members actually wants to make a static site for us. I mean, we're all taking Codecademy courses, right? Okay, awesome. Okay, so that's our code of conduct, and I think that might actually be, yeah. So that's it in terms of an introduction. A lot of the other things that were in the introduction actually come up a little bit more naturally later on. Now we've actually spent the start of this meeting introducing ourselves briefly anyway. I was going to have us fill out a little name card. I'll leave my one up there. So my name's Anthony. I teach in Dubai as a science teacher. I've got a Twitter handle. I don't tweet as often as I probably should. But you can follow me on Ant Copeland, and anytime I do something remotely cool, I'll try and throw it out into the Twitterverse. I don't know if you guys do you want to share a short, brief introduction? So maybe should we start with Nico?
Yes. Yeah, my name is Nico. I'm from Philippines, my nationality, but my location is from here in Rasakema.
Okay.
My role is like what I said, is I'm an interior draftsman in a boat and manufacturer company. And regarding on, that's why I joined it. I just want to see right now what will be the plan of this community. Like what I'm seeing right now is about teaching, also sharing our knowledge to one another. So I'm just also willing to do that because as far as I know, I can also do some static website like what you said. And what else? Yeah, I think that's all.
Yeah, no, that'd be great, Nico.
Yeah.
And Samuel?
So my name is Samuel Landete. I'm from Spain. That's my nationality. I'm located in Dubai right now. Been living here for the last couple of years, and this is my third year in the school. So I teach design in secondary school, in middle school actually, and I help integrate on paper from KG2 to grade 5. What happens in real life is I'm teaching IT from KG2 to grade 5. And that's about it. I teach code. The platforms that I use for coding in KG2 to grade 5 are code.org, Scratch Junior, and Scratch. And in secondary, like up to last year, I was teaching in 6th and 7th grade, and I was using Scratch again, and then MIT App Inventor, and I've also used Thunkable, which are platforms that allow the students to create apps for their mobile phones. That's pretty much it. I've done some like Lego Mindstorms as well. I've done some Arduino stuff back when Arduino 10.000 was released. So that was like 10 years ago or more. I think that's pretty much it. My career is actually, I'm electronic engineer. So I had more hardware experience, but that was 20 years ago. So I don't know if I could remember anything about that. That's about it. Thank you.
That's interesting because we've got quite a spread of experience here, haven't we? Because I've always identified as being mostly involved in JavaScript and Python. They've been the two languages that I've kind of focused on the most. Nico, you've mentioned HTML and CSS as well. And then Samuel, I think like there's such a broad range of tools you've used. And I think we normally refer to those as a sort of low code or no code platforms, don't we? And I think they're absolutely fantastic for introducing students to computational thinking without having that really high threshold of understanding the syntax of what they're using. So yeah, there might only be 3 of us, but I think we're covering most corners of the coding sphere. Okay, that's great. So I said I was going to share a project that I've been working on recently, so I'll dive into that. We're actually perfectly on time right now. We've caught up. So I haven't got a problem per se that I want to share. It's just a success that I've had recently that I'm quite excited to share with as many people as possible. And that's so this slide is just pointing out that there's a Padlet that we can use for sharing these projects. So Nico, if you were working on something but you said you're not quite ready to share it, if you've got anything that you do want to share and there's not a coffee morning coming up, then feel free to jump onto the Padlet that's linked on these slides. I think you just click on the image of the Padlet, and then it will take you to that website. And yeah, you can add projects there just by hitting that little plus icon underneath the language that the project's tied to. And that's a really nice way that we can create a kind of history of projects that we've shared. Okay, you can see from the screenshot I've added my one already, which is called Chemistry with Colab. So just going into Colab and what it actually is, because I don't know how familiar we all are with Colab. So I can just ask you actually, is anyone familiar with Colab, or if not, are you familiar with Jupyter Notebooks?
Nope. Nothing.
Okay, Nico, have you used those before, either of them?
Not also, no.
That's okay. Yeah, no, I'm more than happy to talk about it. So Colab is based off Jupyter Notebooks. Jupyter Notebooks came along first, and they were quite tricky to use because you had to host them. Now Colab is a Jupyter Notebook essentially, but it's hosted on Google Drive. So there's less requirements for you to, install the correct software so that you can make a sort of virtual host or whatever and host it on your machine. And what it does, it allows you to work in both code and then to print those visualizations directly underneath the code. I think can I use the pointer here? Can you guys see that pointer? Is that visible to you?
Yeah.
Yeah. Okay, so this section at the top is a kind of code cell, and that's where I can type in my Python programming. And then as soon as I hit the little play button on the left side, it prints those visualizations, or it prints the output for that code directly below. And I can also add text boxes that use markup. So I can kind of introduce the code, and it looks a lot nicer than just commenting. And then it's really nice that I can have the output of that section of code printed directly below. So in the example here on the right-hand side, I've put in the code that's going to plot a pie chart with the top 10 discoverers of different elements. And then that prints the pie chart below. And then I can talk using the markup language about what my next bit of code is going to do. And then once we get to that next coding cell, I can hit that play button and then it's going to print out the next section of code. So it's a really nice way of introducing a complex kind of series of steps to students quite discussively. Now the beauty of it is that it's hosted on Google Drive, so it plays really, really well with other Google products. And I think, the vast majority of schools out there use Google Apps for Education quite heavily. So for teaching, it's an absolute dream. So that's what a Colab looks like. I started off with my students though, before I introduced them to Colab. Oh, if I missed oh, it might be because, I'll tell you what I'm going to do a sec, guys. I'm just going to stop this presentation because I've added a slide since, so let me just refresh this slide deck. So I wanted to share the actual data with you as well. Okay, so if I go back to share screen, there we go. Okay, so that should give me the, yeah, there we are, there's the missing slide. Okay, so I've introduced Colab. Yeah, so the first thing I gave my students was a quite a big data set in Google Sheets. And then I had them ask questions that they would then try to answer by plotting different types of graphs in Google Sheets. Now they're a lot more familiar with Google Sheets, so this was a nice way of introducing them to the idea of trying to answer a question using a large data set.
Anthony,
Yeah.
sorry, the slide appears, for me at least, super small now.
Yeah, it did for me actually. I was hoping that would be the case for you. Let me see if I can change that somehow.
I guess that, yeah. Okay, fair enough. Yep, perfect. Thank you.
Oh, awesome. So this is a Google Sheet document where I showed them a few different types of graphs that we could make. So this was a bubble chart. And let me try and think now. So I had the atomic number of the element on the x-axis. So we're going right the way up through different atomic numbers. And then I think I've done a really bad thing here and I've not labeled my y-axis. But I think it was the atomic mass that I plotted on the y-axis, and then the radius of the bubble was the atomic radius. So as the actual size of the atom changes, so did the bubble. And then towards the bottom of this sheet, I cleaned that data up by limiting myself just to the first 20 elements. So when we did the first 91, there was just too much overlap. But it was nice actually to show students that process. So, I've tried showing all elements and it's too messy, so then I've cleaned that data by limiting myself to just a more visible number. So I had all this data in a Google Sheet, and then the thing you can do with Colab that I absolutely love is you can import a library that will then authorize Colab. to read your Google Sheets. So I've got rid of the link there just because I don't want people to be able to authorize from my sheet, because that is tied to the student data. But there would be a link underneath this code that I've put in that I would click on. It would take me to my Google Drive, and it would ask if I want to authorize Google Colab to have permission to read my Drive files. So all you do then is you authorize it, you copy and paste a verification code into there, and then that allows you to plot different graphs using Python from a data set that's been brought into Colab. So this is what it looks like in Google Colab. So using that code, I give it the verification code, and then I make a data frame. So I say, right, I want to create a data set that has all of the information in it that exists in this Google Sheet somewhere else on my Google Drive. And then when I print that data frame, this is what it looks like. So you can see all that data from the Google Sheet now has been pulled into my Google Colab file. And that's quite powerful, because then I can start writing. Oh wait, am I missing another? I thought I had. Okay, that's quite powerful, because I can then start using Python to plot different types of line graphs and different types of pie charts and different sort of transformations of that data. So the final thing I challenged the students to do then was to go on to the Python and Pandas programming course and to figure out how to plot a line graph, or how to plot a pie chart, and then to use that data set to plot that type of graph using the Python programming language. And then the final thing that really excited me, again, because this is a Google product, it plays really well with other Google platforms. And that meant that that Colab file that I then made, I could share to my students through Google Classroom, which is massive. And it's just made Jupyter Notebooks so much more accessible for working with students. So I can do most of the sort of heavy lifting. I can put in the code that draws in the data set from the Google Sheet, and then I can put in the code that introduces them, oh, this is how you plot a line graph, and I can include that markup text that explains what we're doing, and then they just hit run as they go along. And then what I did towards the bottom of the Colab file is I put a bit of code in that was a little bit incorrect, and I was challenging the students to correct my code so that it ran properly. So you can make this really nice kind of learning journey for your students, where you're introducing them to different concepts. Then towards the end, you're challenging them to change your code so that it works. And I found that to be a really nice introduction to using Python and the Pandas library to transform data sets with Google Colab. I think that's the last bit. Yeah. Nick, I've just got your name there. Don't panic. It's just because you've marked that you might have a project to share. So that was just a reminder for me in case you did. But yeah, that's what I've been working on. I don't know if anyone's got any questions about that. I don't know how well I introduced it.
No, I get the idea. It's really powerful, and I really like it. So when you execute the code, it only executes the snippet of code.
It does, yeah, and that's quite important to realize actually, because can I go back to a slide where I can show this better? Yeah, here we go. So if I go back to the pointer, if there was something important in this cell, like say I was importing a library that I was then using in this cell, what the students did sometimes is they forgot to run the top cell before running the next one, and then the code doesn't work. So another example is if I declared a variable up here that I was then trying to use down here, I need to make sure that I run this one first, so that variable is being declared to then be used in the next cell down. Does that make sense?
So it executes. It's like going through a program step by step, right? It's kind of how debugging. Instead of step by step, chunk by chunk, you can say.
Exactly.
Yeah. Okay. Yeah.
Actually, in Colab, I I encourage you guys to open up. It's completely free to use. It's just a Google product. So if you Google search Google Colab, it'll take you to a site that immediately tries to open up like an introductory Colab file for you. And then from then on, actually, what I found is that in my Google Drive, when I hit New Document and I go to More Documents, I've got the Google Colab option to just make a new Colab file within my drive. But yeah, within that Colab document at the top, there is an option to run all. And then what that does is it runs the entire notebook sequentially. So it'll run the first cell, run the next cell, run the next cell. And then what happens, which is quite nice, is if there's an error thrown, it will stop at that cell. So you know the exact coding window that contains the problem with your program. So it won't run any further if it encounters any kind of error. Okay. So I'm going to keep using it with the students. The next thing that I want to do, at the moment, this is a data set that I found on GitHub, actually. It was a CSV file that contains all of the elemental data, so I could teach them a bit of chemistry with this. But what I'm interested in doing next is trying to use physical sensors to take some actual data within the science lab, and then using Python to explore that data. Because when we use our vernier sensors, or if we use, any kind of digital sensor in the lab, it tends to take a reading like every half a second. So you end up with a huge CSV file of data. So it would be a good opportunity then to show the students how useful Python can be for working with large data sets. So that's my kind of next step. That's what I'm interested in doing next with them. So the next time I share this project, hopefully I'll be able to say, oh yeah, I've done this with an actual physical science experiment as well now, and this is how it went. Okay. So yeah, that was my project that I wanted to share with you guys. I guess what time are we on now? We're almost 10:45, so that brings us into the next steps bit, right? So in terms of upcoming events and workshops, sorry to throw, kind of throwing you into this, Samuel, but I think we were toying with the idea of maybe doing a workshop on block-based code, weren't we? So, I mean, we're back in work tomorrow, so maybe we can find some time in school to agree on a date for that, and then I can share it out to the chapter community, and we'll see how many people would like to sit through a workshop on block-based coding. Sort of plan that together, maybe give ourselves a week or two to put together the slides, and we'll take maybe half a session each. So maybe I can, if we're both hosts, then I can kind of moderate for you while you're busy presenting, and then we can swap over, and then I'll present, and you can moderate the Q&A or something for me.
No worries. Yep, let's do that.
Okay. It could be good, actually. We could even invite teachers at our school as well. It could be a kind of opportunity for them to do some PD through us. See if anyone's interested in. Okay, awesome, cool. So yeah, that's one next step. I'll send an email out to see if we've got a date for that. Another thing I wanted to share again was the sharing our focus. So I mentioned us having quite a wide spread in the coding languages that we're using. So you can see there I've put my name down for Python, JavaScript, HTML and CSS as well. I'm fine with that. I've also got those coding. But if you guys want to, Samuel, you've already filled out this form, haven't you? And
I did, yeah.
And I think since then I have added you to the document. I think. Let me just open it up and have a look. Yeah, yes, so I put you in under block-based coding. Nico, if you want to throw in any areas. No, I suppose it's difficult for you because you need to indicate what academic subjects that you'd be interested in making coding activities for. So if there's any kind of school subject you'd like to maybe make an activity for teachers to use, you could indicate that through this Google form. And then I can put you in touch with any teachers that are working in the same subject area. So that'd be a nice way of figuring out which teachers specifically you could tie with and touch base with, and then maybe make some activities for their students. Okay. And then, so jump over to the next slide. There's a better meeting times form. This is just if meeting times aren't working for you, but we're all in the same time zone. So I think this is actually an okay meeting time for us. And then finally, just to mention the Discord. But actually, we're both using the Discord. So I suppose this is more for the video. So anyone watching this recording, there is a Discord that you can join. The link's at the top of the slide. I'll put this out with the email. So I'll attach the slides and the video to the email that goes out to our chapter, and then you can click through these slides to get the link to the Discord. At the moment, we are called Dubai. I do want to change that ideally because I'd like it to be open to anyone around the world, just because it's quite a niche. It's quite a niche group, teachers specifically looking to teach with code. So I'd like to open it up to as many regions as possible, just so that we get the numbers in. And also, you know, a science teacher trying to use Python, it doesn't really matter where you're trying to do that. You're probably encountering the same problems, and that'll be the same for most of us, I think. And I think that's it. Is that the last? Yeah, that's the last slide. Okay, awesome.